Exercise 12.2 Problem 13 Discussion. Each individual letter of a word accommodation is written on a piece of paper and all the 13 pieces of papers are placed in a jar. If one piece of paper is selected at random from the jar, find the probability that Part 1. The letter A or O is selected. Part 2. The letter M or C is selected. Okay. It's an interesting problem. We can do it both ways. If you remember, I've been telling you whenever there's an OR, you have to use that A union B. But here I'll teach you or we'll discuss with you how to do it without that method also. Okay, so basically the word accommodation is there and all the 13 letters are written on a piece of paper individually and put in a jar, and they are selecting one letter from that. Okay, so we need to know whether it is A or O. So let's define an event A which is selecting the letter A or O. Instead of earlier what we used to do, letter A be the event of selecting letter A, B be the event of selecting O, and then we do that. You can do that way and you can do it this way also. So what I'll do is that I'll do the alternate method, and you can do by the first method which we have been discussing in the past. You can try it on your own. Okay, now let's go through this. So there are 13 letters, out of which A and O all together is the possible outcome. So how many possible outcomes are there? 1, 2, because O is also considered a positive favorable outcome. Sorry. So 1, 2, 3, 4, 5 outcomes are favorable to you. So probability of getting A or O is 5 divided by 13. Similarly, M and C. So how many M's? 1, 2. Oh, sorry, 2 C's are there. 1, 2, 3, 4. 4 letters, 2 M's and 2 C's are there. So altogether 4 favorable outcomes are there. So 4 by 13 is the probability of getting M or C. So you have to combine these two together as one entity and then see how many of these favorable cases are there. Otherwise, as we have been doing, consider this separately and this separately, that is M separately and C separately, and use the addition theorem. Okay, so this time we will do it by this consolidation method. Okay, so what is given? The word accommodation is given. What have we asked? Probability of selecting A or O, and second part is M or C. So instead of going for probability of A union B and all these things, I am saying probability of A equal to N of A divided by N of S. This point with this formula we will use. Step 1. Let A be the event of drawing the letter A or O. Okay. Earlier A will be for one letter A, B will be for O. But all put together we are saying both A or O is taken as event A and M or C is taken as event B. Okay. Now list the sample space. Sample space is A, C, C, A, comma, C, comma, C, comma, O, comma, M, etc., etc. Okay. What will be the N of S? The number of entities in the sample space. Outcomes, total outcomes. We know there are 13 letters, right? That's what they say. 13 pieces of papers are placed in a jar. Oh, you can count also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So N of S is 13. So total number of letters. And what will be N of A? So N of A, how many A's and O's are there together? So you list out all the outcomes in A and then count it. But you can do it straight away here also. How many A's and O's are there? 1, 2, 3, 4, 5. So N of A is 5. Similarly, you can do for N of B. Right? Thereafter, all you need to do is substitute those values in this formula. P of A is N of A divided by N of S. Similarly, P of B will be N of B divided by N of S. Right? It's a simpler method, but only thing is that this becomes little complicated, or not complicated, little tricky when you have when you have events which are not mutually exclusive. You have to be a little careful. Okay. Anyway, in the revision, I'll plan to do the problems both methods actually, or maybe I'll do that in the next version. Okay, now let's get into the solution. So the sample space is write all the letters, 13 letters here, n of s is 13. Count it, you will see that n of s is 13. So let A be the event of drawing the letter A or O. Both A, if A comes also it's positive, O comes also, it's a favorable outcome. Both are considered favorable outcomes. So the set A will consist of, this will come in, this will come in, this and this and this. So 1, 2, 3, 4, 5. All this will come into this set A. How many outcomes are there? 1, 2, 3, 4, 5. 5 outcomes out of the total 13 is favorable to our case because we are defining the event as drawing the letter A or O. Suppose you define A, how many outcomes will be there favorable? You will have only 1 and 2. And if you define O, it will be 1, 2 and 3. 3 outcomes only. But since we are defining the outcome as favorable to us as A or O, we are getting 5 outcomes. So what is the probability of A? The number of outcomes which is favorable to you divided by the total number of outcomes. Number of outcomes favorable to us is 5. Total number of outcomes is 13. So it's 5 by 13. Okay. The same thing for the part B. Let P be the event of drawing the letter M or C. For reference, I have written the same sample space here. And so which will be favorable to us? Okay. This will be favorable, this will be favorable, or these two C's will be favorable to us. Anything else? I think that's it. So 4 outcomes are favorable to us. C, C, M, M. So how many number of outcomes favorable to us? 4. Count it. Then what is the probability of B? Number of outcomes favorable to us, that is n of B, divided by total number of outcomes, that is n of S. So that is 4 divided by n of S, we know it is 13. Right? So n of S is 13. So probability of B is 4 by 13. Right? Okay. The same thing you can do it by the other method. So you have to define, let's say event C or maybe event D is selecting letter M and find the probability of M. Says event E is selecting letter C and how many find the probability of E, and then use the addition law and get that also. Both ways it will come to the same value. Okay, but I suggest you try that method on your own, and I'll try to add this as an it's a later in the later part of the session. I'll try to add one extra area section where alternate methods also I'll include. Okay, so I hope I made it clear. If not, please go through this problem one more time. It will become clear. Thanks for watching this video.